simple. We will just be importing the rooms into it along with the associated 3D geometry into Dynamo. So let's switch over to Dynamo. I hope everyone can see the screen and hear me. So as usual, since we are starting with selecting Revit elements, we'll go into the Revit tab, selections, all elements of categories, and then select the rooms. Manual, run. So we got all the 5 rooms that are there in the model, but we still don't have their geometry. In order to obtain that, we need to get each element geometry with the element.geometry command. Yes. Now if we switch to geometry view, we can see we have the 3D of all the rooms that were there in our model. Now we can process this further and obtain more information from the model. So you can see we have a like list within a list over here, which we don't require. So we can simply flatten them since there is only one solid per room. So we have a flat list of solids. So if we want, we can get information such as what is the volume or the surface area of each room. So if we type in volume, it gives us a number, okay, whatever it is. And what we can do is we can further color the data that we have over here based upon this volume values that we have. So to visualize the rooms better. So what we can do is get the max. Yeah. Divide it. And input this. What we are doing is simply to establish a range from 0 to 1 for all of the elements that are here, because so that we can color them easily. So now we will go into color range. Yeah. So this is a color range which takes a number of inputs, the first of which is the color, which is a list of colors which specifies the start and the end of the color range. So we will use list, data item with 2 lists, and let me move this a little bit over here. Yeah. So color palette. Yeah. So say we will have 2 colors. We will start with green, and then we will move the color range as the volume goes higher and higher into red. Okay, so this is red. And then the indices, which is either a value for each of the colors that you are inputting over here. So since we have inputted 2 colors, we will again input a list which will specify what is the, say the green will be the start and the red will be the end. So this is 1, 0 to 1. So delete, sorry, my bad, I did another thing. Delete, number, 0, this is 1, indices. Yeah, and so then there will be the values, which will be the list of values that will be picked as along with the color range, which again needs to be from 0 to 1. So that's why we converted this into a range from 0 to 1. We'll input it over here. And now you can see a color range has been created from green all the way to red. And now if we take this color and apply it color by geometry. Okay, something. Okay, sorry. This was has to be the geometry. I inputted the double in it. So if I input this, yeah. So it has colored all the elements based upon the values of its areas. Okay, so you can see the larger blocks are red, and as it goes towards the green side, as you can see brown, those have smaller and smaller areas. So this color range is created based upon the volumes of the room. So this we can do with any other property such as area, surface area, anything like that for any other element as well. Okay. Any questions so far regarding how to create a color range and how to import an element into Revit? Sorry, from Revit into Dynamo. Okay. So this was the basic. Now we will just go into something a little bit more advanced, which is, as you can see over here, we have a number of walls, all of which are say 215015 brickwork, but we don't know which of them are external walls and which of them are internal walls. So what we'll do is we will analyze the model to find out which of these walls are external and which of these walls are internal. Visually seeing this, we can say for like it's easy to identify like 1 2 3, but that has to be done manually, and especially if it's a bigger project, it's much more difficult to specify it manually. So what we are going to do over here is we are going to automate this process. Okay, so let me close, switch over to a new tab. So since we are working with the walls, we will again start with the first task, which is getting the walls from Revit. Sorry. And then we will select category. Let's switch this to manual. And again, similar to the rooms, we will get element.geometry. So here we have the wall geometries available, but currently each wall is still a solid. If we check over here, we can see that each of the walls is still a solid, okay, which we don't want. We want to go a step further, and we want the individual surface of the room because each wall will have an inner surface and an outer surface. So let's break this down. We can use the explode command. So if we use this explode geometry, so what explode will do is explode will take each of the solid geometries of the wall and split them further down into smaller surfaces, like it has done over here. You can see now from solids we have gone into each and every surface. Yep. So, and you can see it's a list within a list. This we don't require as it will add complexity to our graph as we move forward. So we will simplify the list over here. But if we simply run a flatten, in this case, it will flatten everything up. That is not what we want. We only want this hierarchy level to go away. So this is a level 4 list. We simply want to turn it into a level 3 list. So we will run it at the sub level listing like this. Yep. So now you can see we have a list of surfaces corresponding to each of the walls that we have collected in the first step. So there are 9 sublists containing surfaces, and we have 9 walls over here. Okay, sorry, 0 to 9, that means 10. Okay, so we have the surfaces of each of the walls over here. Now what we need is we need the like the larger surfaces, because each surface you can see there has a number of options, right? One, two, three, four, five. We don't require 5 surfaces. We only require the 2 of the main surfaces of each wall, like the left and the right face. So in order to do that, what we will do is get item and index, list, number. Specify a index for it and say specify 1. Okay, so what it does is it fetches this list number 1, but that's not what we want. We again want to go and work it for the list below it. So for a sub level, so we will enable level and run it at level 2. So yeah, now it should give me 10 surfaces. Okay, and as you can see over here, these are all the inner surfaces of the walls. You can see it has become highlighted in blue. Okay, this depends upon whether on this side or that side is based upon how the walls are drawn. But here you can see all of them are the inner surfaces. Okay, if you switch to node, so what we will do next is get the other larger surface. So we have one of the larger surface available. We will get the other larger surface, which is 4. And now if I select over here, you can select, see all of these surfaces have been selected. So now there may be a question like, how are we knowing which index to get select so that we can get it? So Revit has a, like Dynamo has a typical way of breaking down common Revit objects such as walls, floors. When it come, like when you explode a solid which is a wall or a floor, it normally tends to follow these rules, like 1 and 4 are the larger surfaces if it's a simple wall. Now if it has more complex objects, okay, then it will keep on getting more difficult and difficult to select, and here we have to like check and filter out to get these 2 surfaces. So what we have done over here is, if I hide the preview till now, I have just got the 2 edge lines of the walls. Okay, I have filtered out all the other surfaces and have only the 2 main surfaces of the wall. Okay, any questions so far what we are doing? Okay, so now since we have both of the main faces of the walls, what we will do is we will simply draw a vector over at the center of it. So what is a vector? Vector is nothing but a direction in which something happens, like a, like say a number is a only tells us the magnitude of something. Vector also tells us in which direction that magnitude is, in x, y, or z. Okay, so if we go into geometry, surfaces, so if we go and do normal at parameter, we get this node and we plug the surface in. So what is u and v? So every surface is divided in the into 2 parts, u and v, which is creates a grid on it, and this grid extends similar to curve extent is from 0 to 1 on both x and y direction. So if you want the center point of the surface, you can simply type in zero point 0.5 over here as the parameter for both u and v, and you will get the point which is at the center. In this case, we want to draw a normal at the center of the surface, which we will do over here like this. Yeah, so we have all the vectors generated for this surface. Similarly, we are gonna do for this one. Yep. So we have generated both the vectors, but this is currently we cannot see because it's just a direction over here. What we'll do is we will add a line to it. We will use this point at parameter, which is similar to normal at parameter. The only difference is we will be using the surface to create a point instead of a vector. So let me plug the same thing in, and let me plug the same thing in over here. Okay, now you can see a number of points has been created throughout the model, like this, the black dots that you see. What we are going to do further is we are going to add a line to it. Let me just select the line command. Yeah. So what the three inputs the line takes is a start point, a direction, and a length. Okay. So the direction will come from the vector. The point will come from this, and the length we can type in, say, 500 in this case. Yep. So let me copy the same thing down as well. Okay. So we are using the vector to create a number of small lines in each of the surfaces from the center point. Okay. Like we have done over here. So you can see all the surfaces now have these small lines coming out of it. So what was the requirement for this? The logic was, since we have these walls and we have the small lines jutting out from each one of them, the logic is if the line is inside a room like this one and this one, okay, and the line on the other side is also inside a room like this, so that must mean this is an internal wall. But if any one of the two lines, the endpoint of the line is not within a room, that means the wall is an external wall, like this one. Okay. So this same logic, what we are talking about over here verbally, we are gonna script it in into Dynamo, so Dynamo can also understand it. So we have the lines over here, and we will get the endpoint. So curve dot endpoint, and again curve dot endpoint. We have 2 points over here. Yep. So we have got all the endpoints over here. So now what we are gonna do is we are gonna get all the rooms, since we know we want to detect whether these points lie within a room or not. Again, what can I simply do is copy the all elements of category. Yep. Instead of walls, it will be rooms. And there is a node called room inside. Room inside is inside room. Okay. So what this node simply does is it checks whether a point is within a room or not. So what we will do is we will feed all the rooms in. Okay. And now what we want to do is we want to check and feed each one of the points in one by one into this node. Okay. The problem is if we connect like this, it will run. Okay, but it will only generate a small list like this. This is not what we want. We want the points to be fed in one by one. Okay, and to be checked for all the rooms. In order to achieve this, what we will do is we will use something called list map. okay, which is equivalent to a for each. Okay, so let me do a map. Yeah, so this is a list map command. So this is a little bit different than the other commands, but it is one of the most powerful functions that is out there, like nodes that is out there. So what it does, it instead of pointing these points into this one, we'll point it into the list command, and we'll output the end of this over here into the function. This will keep empty. Okay, so now when we run it, you can see all of this changes to function. Nothing we can see over here. But here we get a list of true and false, which corresponds to each of the points. Okay. So what is happening over here? So the script is running in a such a way that for each one of these points, it is being checked against all of these rooms, 5 rooms over here. So point one over here, which is x1 minus 1972, is checked against all of these rooms, the 4 rooms. So, and it is found that this point is not within any of these rooms, and so on and so on. It continues. But over here, you can see for point number four, it is within room number one. So it has returned true. Okay. So this is list map. It is running each point against this entire function one at a time. Okay. So this is similar to a for each in a programming language such as Python or C sharp. Any query till now, like how list map works and what we just did over here? Okay. Correct. Yeah. So we have a list of number trues and false over here, whether the point is within a room. So what we are trying to ask over here is whether the point, or in this case, this point is within any of the rooms. We don't care whether it's within room one or room two, because if it's within any one of the rooms, then we can conclude that at least one of the faces of the wall is adjoining a room, right? So what we'll do is we will list true. Uh, just type in true. Any true. So what would this will check is this will return true if any item on the list is true. Okay. And again, we don't want it to run at the top level. We want to run it at the sub list level. So we will again select to use level 2 and run it. So now you can see the top 3 are all false because all the sub lists are false. One, you can see all of them are false. All of them are false and so on. Okay, so all of this is false. The first true we get at list number 4, this is 4. So 4 has one true. Therefore, it has returned true. At least one room it is adjoining. Again, similarly for 5. Okay. So it is only true if at least one of the values within the list is true. That means the point is within a room for at least one of the rooms. Okay. It may not be inside the other rooms, which obviously won't be the case because the wall will only bound a particular room, but it is at least inside one room. So we can know if it is true in this case that at least one of the face of this wall which we have selected is adjoining a room. Okay. And what we are going to do now is we are going to take this same logic. Okay. Control C it, Control V it, and run it for this points over here, which is for the other set of surfaces that we have. Okay. So like this, right? So this is for the inner set of surfaces. Okay. And you can see all of them return true because each and every point at least return are at least within a room since they are all inner facing. So now we have two lists, one for the inner surfaces, which are this, and one for the outer surfaces. Okay, that is the two faces of the wall, irrespective of whether they're inner or outer, telling us whether they adjoin a room or not. Okay, so this set also we have a list, which is this, telling us whether they're adjoining a room or not, whether the surface is the surface of a room or not. And then we have this list, okay, which again gives us similar information. For example, this is adjoining a room, but this is not. So we have variation of true and false over here. So what we want to do over here is, yeah. we want those walls which at least one of the sides is false. Okay, if both side is true, then it should be true. If one of the side is false, the other, even if it's true, it's still, we don't want it to be a false, because then we know it's an external wall. So what we'll do is we will type in a formula over here. So if we type in formula, this function appears. Okay, this is a formula chart. Here we can type in any kind of function we want. Okay, there are certain syntaxes to it. Now I will be doing a simple if then else statements. So if the first part of the if then else is simply the what if and start bracket and then the condition. So the condition what we want is we want both of them to be true. So this output to also be true and this output to also be true. So what we'll do is we will write x and. So this is a operator, the and symbol in this case, which compares to Boolean value. So x and y, if both of them are true, it will return true. Okay. And if either one of them is false, then it will return false. Okay. Now if we plug them in, okay. So we have a list. Okay. So you can see 01 is false. So it's a false in spite of this being a true, because we gave it a and condition, which is we want both x and y to be true, then only it should return true, or else it will return a false. So we have this list of true and false over here. So what we can do over here, we can see we have 10 items, which is equivalent to the number of walls that we started with initially. Okay, so what we can do is we can use a filter by Bol mask. Okay, and use this output as the mask of it. Okay, and then filter out all the solids. Yep. So let's me flatten the list out, whatever it comes out, since we don't need a hierarchy. Okay, now we won't see anything. Now if I switch off the preview of all the other items, you should be able to select and see this. So now if I select this, you can see the in node, like whichever has passed the test, are all the internal walls. Okay, you can see those has been filtered out. And if I switch and select this one, you can see all of this are the external walls. Okay, we can further emphasize the difference with using the color by geometry node. So geometry. If we give, say, this a blue color and this red color, let's switch out the preview. Okay, so now you can see it has separated out the walls into interior and exterior. Okay, and colorize them. Okay, so while this logic may be similar to us to understand visually, but if we want to detect it for a large project automatically, okay, with Dynamo, then we have to go through this process, which is less like mathematically telling Dynamo what is an external wall and what is an internal wall. Okay. Any questions till now? Yep. So that's it from my end for today. Okay, if there are any questions, we will take them. Like I covered a lot of, what will I say? At least feel which are complicated stuff such as the list map and like extracting geometry and splitting them, exploring them in Dynamo. So if you have any questions, feel free to ask, or else we will conclude for today.
Hi, Saurav.
Yeah,
Can we get the colors of?
yeah. I cannot hear you. Somebody saying something? Sagar, can you hear me?
Yes, sir.
Yeah, was someone saying something?
Yeah, Vaibhav was saying something again. He's on mute.
Okay.
Hi, Saurav.
Yeah, yeah,
Uh,
Stuck again.
can you
uh,
hear me?
Yeah.
yeah, yeah. We can hear you. Yeah,
Okay. So my question was like, we are able to color here in
yeah,
Dynamo, but can we
yeah.
change the colors of the subcategories in the Revit from Dynamo?
You can add a parameter, then a filter. Okay,
Mm-hmm. Okay.
like that. Like if I want to, instead of like coloring over here, I did this simpler. Since you have the split, you can set a parameter for the walls as
Mm-hmm.
well, right? And then use a
Yeah.
filter to color it in Revit.
Okay. Okay. What is the name of the node?
Which name of which node?
To Yeah, to change the color in Revit. Like,
Elements dot override in view. Okay,
okay. Okay. I'll just type it
okay,
in.
yeah. That you can do, or you can just if you don't want to, what will I say, do that in Revit, you can just use the Revit set parameter over here. Like set the parameters in
Okay. Yeah.
using Dynamo, right? Where is the element command? Just use this node to say
Okay.
write it into the
Yeah.
comments or something like that. Say
Mm-hmm.
exterior and interior. Okay, based
Okay.
upon,
Set
since you
parameter.
have two separate list over here. So if I do it right now, what I will do is I will copy it, and instead of taking the solids, I will take the walls itself. I have the walls over here.
Okay.
Okay, so if I split it now, I have
Mm-hmm.
a list of walls. Okay, I will do set parameter and out set parameter, and I will give the name. Say I will use comment over here, but you can use anything that you want. Okay, comments is already
Okay.
exists,
Yeah.
but if you add something else to
Mm-hmm.
your list, that also works. So this is comments,
Okay.
comments, and I will just add a string. Say something like this is interior,
Mm-hmm.
and this we will add as exterior. Mm, because at the end of the day your specification for the walls will be different if it's interior or exterior. Maybe you have done it with 200 for the LOD 200 stage, but going forward you will be changing the type, right? So you can see
Yes.
over the comments we have the exterior value, and for the interior we have the interior value. Now what I will simply do
Okay.
is
Yeah.
add two filters, right?
Okay. Yeah. Now I understood. Yeah.
Yeah, so if I just do a interior wall. Like this gives me much more control than doing it from within Dynamo. I can override from within Dynamo also. I will show you the node. Okay, and similarly, I can do the external wall also. So within Dynamo, there is this node called override in view. Okay. Override view. Copy it. Mm, like it's similar to the element dot override that we use like this. Okay, it's similar to that. Okay, that also we can use, but this method I think is better, like setting it a parameter and then using filters. Yep. Where's- mm, this is one of the. This is for category overrides. There is a element level override also. This one override in view. So if you use this node, you can override each and individual elements with the like similarly to what we did over here. So you will plug the elements in, then the overrides in, and then run it, and it will override, which will be equivalent to doing this, like selecting and overriding like this. Yep.
Yeah, understood completely. Thank you.
Yep. 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 Thanks. Any other questions anybody has? If not, I think we can end the session for today. If somebody has any questions, we will take them, or we will call it a day. Yep. Yeah. Yeah. Sagar, I think we can end it. There is no more questions. Yeah.
Yes, sure. Yes, sure.
Yeah. Yeah. Thanks. Thanks, everyone.
Thank you. Bye.
Bye. Bye. Thanks.